everyone. I'm Susie Valdez of Labroots, and I will be your moderator for this event. Thank you for joining us for our presentation titled Standard Test Method Development Process at ASTM. It's my pleasure to introduce you to our speaker, George Gonzalez, the Director of Global Segment Marketing at Agilent Technologies, American Society for Testing of Materials, and the Chairman of the Subcommittee D02D. For complete biography on our speaker, please visit the tab at the top of your screen. And if you have any questions that arise during this presentation, please, we encourage you to submit them in the Q&A box. Our speaker will address those questions following his presentation. Please join me now and welcome George Gonzalez. I will now turn the presentation over to him. Welcome, George.
Hello, everyone. My name is George Gonzalez. I work for Agilent Technologies, and I am here to present the standard test method development process at ASTM. I'd like to begin with the agenda, and the first thing I'd like to quote from the ASTM.org site, the following, which is the ASTM process transcends what entities could do individually because it bridges gaps of technology, combines resources, and overcomes lines of competition. The result is a product of the highest credibility, integrity, and marketplace acceptance. That is the core of what is done at ASTM to develop standards. In this presentation, I'm going to begin by discussing the overall structure of the committee and specify a few details. And of course, the standard development process is by consensus in the development of all standard test methods. I will also cover standard development hierarchy and how it processes through the ASTM promulgation process. There's a hierarchy, and I will review that and provide more details. The balloting process is an iterative process and requires a ballot at subcommittee and a ballot at main committee to be approved as a standard test method. The balloting process will be reviewed in detail in this presentation. And then the big question is, why does it take so long to develop an ASTM standard? If you follow the development of ASTM standards, you'll see that it requires in the order of 1 to 3 years. The promulgation time will be discussed as well. And then to augment the description and give an example of a collaboration that was performed in the development of 2 ASTM standards, I will provide that example as well. And then I will also provide a few standards that I am working on that currently are in the development process. The first item on our agenda is the fact that ASTM is a voluntary consensus development program. It is composed of many committees. The one that I am most familiar with and I attend regularly is ASTM D2, which is Petroleum, Products, Liquid Fuels, and Lubricants Committee. It is part of the numerous technical committees that were formed to address specific industry needs, such as those noted in the title. The main committee is then subdivided into subcommittees. The subcommittees are there to address subsets of specialized subject matter. The main committee has an executive subcommittee which oversees the subcommittees, and that is D2.90. Then there's lettered subcommittees for product specifications. So the product subcommittees are designated by a letter, for example, D2D, which is the Subcommittee on Hydrocarbons for Chemicals and Specialty Use. Now, in this case, I am the chairman of this subcommittee. Then there are property subcommittees, which are designated with a subcommittee number. For example, D23 is for elemental analysis. And then there are coordinating subcommittees, for example, subcommittee 91, 92, 93, etc. And those are, for example, statistical quality and numerous others coordinating committees dedicated to supporting the process of ASTM standards. Now, the subcommittees form task groups based on the need to support an active ASTM standard, one that has already been published and is being revised, or a task group may form to work on a new standard test method. So the task groups are formed by experts from the industry to form subcommittees that are organized into groups to write standards and to revise standards that are currently active. Those task groups form the core source of work at ASTM. They perform all of the actual coordination of sample logistics. They perform the pilot studies. They coordinate the inter-laboratory studies. They write the ASTM standards. And with regards to writing ASTM standards, there are specifications and requirements that each standard must meet. So these are all defined in the ASTM regulations for procedural process and promulgation of the standards. And then the document itself must comply with the standardized format, and that is based on ASTM Form and Style Manual, which contains the directive and instructions and specifications that are required for each standard. So each standard meets the minimum criteria for formatting and the style for and before publication. The next item on our agenda is the description and of the process in the standard development hierarchy. As I mentioned before, the bulk of the work is performed by the task groups. The task groups play the most, if not the majority, of the work in the development of a standard. A standard begins with a technical presentation presented at either of two in-person stated meetings held either in June and December. This year, unfortunately, the in-person meetings were canceled due to the pandemic and the effects. So most of those meetings and all of the coordinating meetings were held by teleconference. The majority of the work, which includes the technical presentation, then it moves to a request for a work item, which is assigned by the subcommittee. A task group is then formed and assigned to that work item. The task group is composed of technical experts from the industry who are working to develop a standard for common use. And then the draft document is circulated within the task group expert panel, who then agrees on a final draft, which is used to perform a pilot study based on ASTM D6300 criteria. The results of the pilot study are then used to design the interlaboratory study, which also has requirements and are also stated in ASTM D6300. The interlaboratory study is for the purpose of collecting test data, which is then processed for statistical analysis, and the results are published as the precision and bias statement of the standard test method. Once the task group completes their work and there is agreement, on occasion there's some unofficial voting within the task group to assure that consensus at the task group level is met. However, it's unofficial, and in most cases, any dissensions or disagreements on a technical matter are addressed at the task group. Once there is agreement, however, at the task group level, the proposed standard test method is submitted to the subcommittee for balloting. Balloting is performed by electronic basis, and it normally takes approximately 30 days. The ballot must have a 60% return rate with 2/3 approval in order to move forward. Now, I'll not mention the items that may hold up or cause the ballot to fail, and those are negative votes. I'll explain that in the detailed review of the standard promulgation process. If the ballot passes at subcommittee, then the item, the proposed test method, is then balloted at main committee, which has the same criteria, and it also has the same 30-day balloting process. If it's approved at main, then it moves to Committee on Standards for final review, and it also has a 30-day ballot review with due process, and it also has an appeals process at that point. So that is the general hierarchy of how a standard moves through the ASTM process. The ASTM balloting process begins with a defined industry need for a standard. On occasion, there are test methods that become common practice in the industry, and those are based on a need to measure a given parameter of a product that is commercially traded. The original work is performed at a laboratory, and then the industry method is then shared within the industry, and it suddenly becomes prevalent, but is not a standard test method. So in those cases, when there are at least 6 laboratories that are using an industry method that has not been published, it is possible that that is an identified need and justifiable as a proposed test method. So when that becomes necessary, this industry need for a standard can then be presented at a technical presentation at a stated meeting at ASTM D2. As I mentioned, those meetings are held in June and December. And they're held and conducted in several cities within North America. The technical presentation then provides access to a work item. Typically, the person presenting the technical presentation is considered the technical contact for the work item. And that person will then lead the effort and the task group in the development of a standard test method. The task group then moves on to collect data. First, as I mentioned, there's a pilot study based on ASTM D6300. Then there's an intra-laboratory study, or ILS, that is used to collect data for the precision and bias study. And then the task group will draft the proposed standard in the final form to be submitted. The proposed standard must meet with ASTM form and style manual criteria before it's submitted for balloting. The draft is then approved at subcommittee for balloting. The ballot then requires and is open for 30 days. It's an electronic balloting process. The balloting process is open to voting members of each committee and subcommittee. So during the 30-day review and balloting process, each member can either vote affirmative or negative. If there is a negative vote, it requires a comment as a technical concern regarding the proposed standard. If there are no negatives, the ballot item with the proposed standard moves on to main committee ballot. However, if there are any negatives, the rules of the balloting process state that all negatives must be resolved before it can move on to the main committee ballot. So if there is a negative, the technical contact for the work item works to resolve any negatives and comments. And then there's a decision tree. If the negative comment is persuasive, but it is a change that is not editorial, then the standard is revised and sent back to the subcommittee for reballoting. If through the resolution process, the proposed or required change concerning the negative is an editorial, or if the negative is withdrawn after discussion, or in the worst case, if the negative voter refuses to work with the technical contact in resolving the negative vote, it is possible to find the negative vote non-persuasive. That process requires presentation of adjudication at a stated meeting during the June meeting or the December meeting. So if the vote is editorial and can move on, or if the negative vote is withdrawn, or if it's found non-persuasive, then it can move on to main committee for balloting. The main committee balloting process requires 30 days. And again, it goes through the same process during the balloting process. If you have negative votes and comments, they have to be addressed. And the same decision tree is used to resolve negatives, as in the one that was described for the subcommittee. If there are no negative votes, the standard test method moves on to the Committee on Standards for review and then published after that. So the big question, as I mentioned, most people have regarding ASTM standards and some other standard development organizations. It takes time to develop a standard. And the big question is, why does it take so long? And the answer is, it takes as long as it takes. And as I mentioned also, that each standard test method is unique. It also, as you may consider, requires resources. It requires materials. It requires instrument time. It requires a shipment of samples to each location. And then, more importantly, it requires a dedicated effort of a collaborator to run the samples for both the pilot study and the interim laboratory study. So all of that work, as you might imagine, requires a significant amount of time. And in the process, there are an unknown amount of variables that require time to complete. So in this process, as you notice the timeline, the pre-work performed by the task group in the process of method development and establishing the precision through a precision study, and all of the work I just mentioned requires X amount of time. And I can't begin to express that the more complex methods require a significantly more amount of time. And then the work item begins at time 0. That's as the work item is presented. And then, of course, then you have the balloting process at subcommittee ballot at about 6 months. And then the main committee ballot, if it passes directly to main, that's 12 months. And then review and publication. So the fastest possible completion is 1 year. You have the technical presentation, the work item, and if the standard has already been worked to a point where the precision study and all of the work has been completed to that point, then it can be completed in 1 year. But more typical, it requires between 18 to 36 months to establish and publish an ASTM standard. Now, there's also additional time required because at the 5-year mark after publication or last revision, there is a review of the standard. That means that the standard must be reviewed by the subcommittee and reballoted for reapproval. So all standards at ASTM are reviewed at least at minimum every 5 years in order to be continued in publication. So you see, these are all variables that answer the question, why does it take so long to publish a standard? As you can see, there's a significant amount of work for each standard required. What I'd like to do now is provide a collaboration example of one that I am personally acquainted with. We at Agilent started a collaboration to establish 2 ASTM standards. As you may see, there is ASTM standard for crude oil, the elemental analysis of crude oil and residual fuel oil by MPAES. That standard was published this past July, a couple of months ago. And at the same time, a standard test method was in promulgation concurrently at the same time as the one that has already been published. So that gives you an idea of the complexity of even using the same platform, the MPAES, to run three different types of fuels. The collaborating team is shown there. It was a global collaboration with 12 laboratories performing the pilot study and the inter-laboratory precision study. That is our collaborating team shown at the bottom left. Now, what I'd like to do is briefly go over the timeline for the development of this standard. The program timeline to establish the 8322. We began and presented the technical presentation at the ASTM meeting in June of 2017. In that meeting, we requested 2 work items, one for what is now D8322 and one for the second proposed standard, work item 56916. That proposed standard is still in the balloting process. The pilot study for this test method was completed in July of 2018. The work to establish and get to a pilot study, as you can see, is just a little over 1 year. And that's coordinating shipment of pilot study, preparing the samples for the pilot study, and everything involved with distribution and testing, completion, and processing the statistical data. It required approximately 1 year. The inter-laboratory study, which is a much more rigorous study, required that each laboratory test 3 fuels, 2 for crude oil and residual oil, and the biodiesel samples. That inter-laboratory study was completed in March of 2019. Both of these proposed standards were submitted for subcommittee ballot in May of 2019. They were concurrently performed, all 3 of these inter-laboratory studies. There was an inter-laboratory study conducted for crude oil, one for residual fuel oil, and one for biodiesel. They were completed and then inserted and added to the proposed test methods as a precision for each proposed test method. That ballot submitted in May of 2019 received a negative vote, which required adjudication and resolution. The negative vote could not be resolved without significant changes to the standard. And in this case, the majority of the concerns or negative comments were related to the description of the working range and the valid test result range, defined as new items in ASTM D6300. The ASTM D6300 defines the precision and bias criteria, as well as the working range and the valid test result range. That caused confusion, and significant changes were required to the proposed test method. So we had to reballot in July of 2019. That ballot also generated additional negatives, and I adjudicated that negative at the stated meeting in December of 2019. That negative was found non-persuasive. Therefore, the proposed standards moved on. As far as D8322 is concerned, it moved on to main committee ballot. Now at this time, the second standard had to be reballoted at subcommittee for a third time. So that's not shown here, but it started falling behind. Then the main committee ballot produced no negative votes. There was one item that was resolved, and the standard D8322 was published in July of this year. So that's an example of a collaboration of two standards performed by the same collaborating team using the same instrument platform. However, one of the work items moved on to be published as D8322, and the second work item is still in ballot. And as of this moment today, I'm working on some negative votes at the main committee. So that gives you an idea of the challenge that we're up against when we're establishing an ASTM standard. And it can also provide some insight to the robustness of the process at ASTM. So the current standards in development at ASTM, those that I am working on, are shown here. Now the first one is there basically because it just went from work item status to published ASTM standard. And that is the standard test method for determination of elements in residual fuels and crude oils by microwave plasma atomic emission spectroscopy, the MPAES. That was published in July, and we've moved on. The next item is the second standard, which is still in work item status. The work item is 56916. Again, the only difference there is that the test method is for determination of elements in biodiesel blends up to B100. If we work through to resolve the negatives currently on ballot, I hope to complete that by the end of this year in December. The other item that I am working on is at committee D2.4 subcommittee M for mass spec. The test method for work item 50453 is the standard test method for determination of chemical species in marine fuel oil by multidimensional gas chromatography mass spectrometry. We are currently in the process of conducting an inter-laboratory study for the precision and bias statement of that standard. D7845. In addition, we have a second work item with a request that we received for expansion of the scope. So that's work item 56072. The expansion of the scope for this test method includes components which cannot be performed by the current sample preparation procedure. So that requires twofold. It requires a new sample preparation procedure as well as an inter-laboratory study when we complete that. The goal is to develop the new procedure for the additional components and incorporate the new procedure as procedure B with the current procedure in D7845 as procedure A. I am currently collaborating with Intertech on that work. Then we also have some joint work with Bureau Veritas as we revise ASTM D8110. At present, D8110 was published with conditional provisional precision data, and it's for the elemental analysis of middle distillates by ICP mass spec. The goal is to expand the scope of the element table capabilities and to include crude oil analysis by ICP mass spec. So those are the standard test methods that I am working on and moving at ASTM. So one note, and to make sure, the information that I provided is based on my experience and the resources that I have at ASTM.org. I would recommend and suggest that you join ASTM and possibly attend the biennial meetings if you're interested in participating. And also, and more important, as you might have noticed, there's a significant amount of work performed by the task groups. And as a technical contact for multiple standards, it is challenging to find participating labs. And I truly understand why, because I've managed laboratories in the past at contract labs, and I know the volume of work that is performed in most laboratories. It makes it difficult to add additional load of sample testing to participate in an ILS. But it's vitally important to continue to expand the volunteer list so that we can have additional support and resources that help to develop standards. So you can go to the website astm.org and get all of the details required beyond what I obviously have provided here. And in closing, the disclaimer is that this is not inclusive of what is required to establish a standard. It is merely an overview. And if you need additional details, you may contact the staff at astm.org. Thank you for your time today. I believe we're moving on to the questions and comments section of the presentation. Have a good day.
Thank you, George, for that outstanding presentation. We will now move to the live Q&A portion of the presentation. As a reminder, please submit your questions via the Q&A box. We welcome all questions now. George, our first question from our audience member is, are all of the subcommittees organized the same way?
Yes, for the most part, the difference is going to be with the task groups. Some are more specialized in terms of being able to address the requirements for each specific standard. As I mentioned, all of these standards have different procedures, different apparatus, and different capabilities. So the task group can expand and it may have on the order of 100 or so collaborators participating in the task group. So effectively, they're all the same. It's just the size and the number of participants in each task group.
And what about membership? Do we have to be a member of ASTM to participate?
So that if the person is interested in reviewing and the standards as they're balloted in the electronic process, you do need to be a member for that process. And when you join, you select the committee, which would be in this case D2, and also you need to select the subcommittees that you're interested in, and they're all listed on the website. So once you do that, as ballots are rolled out electronically, you will receive an update, and as you can access the ballot on the ASTM website. So that part, you do have to be a member. However, there are quite a few labs, you know, as I mentioned, for the interlaboratory studies, not all of the folks that are participating, running the samples, and even for the expert panel, they're not all members of ASTM. They're folks that volunteer their time to develop a standard that can be used in their lab and shared for the industry. So for participating within the task group and all of that work, donating chemicals and reagents and you know, other things, all of that is effectively the majority, as I mentioned, the majority of the work to develop a standard. You can also participate in drafting the method and adding your comments and your experience and your expertise. You can join the task group, but you do not have to be an ASTM member for that.
Georgie Gonzalez, thank you again for your presentation today and for your important research. And I want to thank our audience for our outstanding questions throughout the conference. Any questions that were submitted and not answered today by our speaker will be addressed via email. And this presentation will be available for on-demand viewing through September 2021. Please share it with a colleague who may be interested in today's topic. And thank you again for your participation. We hope you enjoyed the Agilent Science and Technology Virtual Symposium. Until next time, stay safe, stay healthy. Bye-bye, everyone.
Bye.